Hello everyone, this is K.Hari Babu, working as Associate Professor of ECE Department in MLR Institute of Technology. Today we will discuss about total probability theorem and Bayes theorem. Total probability theorem. The sample space S having n mutually exclusive events will be taken as n equal to 1, 2, 3, so on n, that is B1, B2, B3, so on Bn. Bn intersection Bm equal to phi. There is no common between those two. That is n not equal to m equal to 1, 2, 3, so on n. Here I want to define event A on this sample space. Then the probability of event A is expressed in terms of conditional probability Bn, that is P of A is equal to summation of n equal to 1 to n P of A by Bn into P of Bn. This is the statement of total probability theorem. See here what I am telling. This is the sample space having n mutually exclusive events, that is B1, B2, B3, so on Bn, and all these are mutually exclusive, that is Bm intersection Bn equal to phi. Now what he is telling, event A is defined on this sample space. Now I want to find the probability of event A in terms of conditional probability B is written as P of A equal to summation of n equal to 1 to n P of A by Bn into P of Bn. Now we need to see the proof of this one. Proof. Here first point is all these elements are mutually exclusive, that is B1 union B2 union so on union of Bn is equal to sample space. Point number 1. Second one, what he is telling, now I want to define event A on this sample space. So here event A is defined on this sample space means now I want to find the common between A and S. So here the common between A and S means simply you can get A only. Now what is meant by this S? S is the combination of all the mutually exclusive events. So I can write A intersection of B1 union B2 union so on union Bn is equal to A. That is, see here B1 union B2 union B3 union so on union Bn, simply we can write union of n equal to 1 to n Bn. So we can continue like A intersection union of n equal to 1 to n Bn is equal to A. Now I want to rearrange this equation, that is union of n equal to 1 to n A intersection Bn is equal to A. Now I want to apply probability on both sides, that is probability of union of n equal to 1 to n A intersection Bn is equal to P of A. Here by using third axiom, what we know, that is union of n equal to 1 to n is also equal to summation of n equal to 1 to n in the case of mutually exclusive events. Now I want to apply that axiom here. So rearrange above equation like summation of n equal to 1 to n P of A intersection Bn is equal to P of A. So this is the total probability. If you want to expand this one means, that is P of A is equal to summation of n equal to 1 to n P of A by Bn into P of Bn. You can expand like P of A is equal to P of, for example, n equal to 1 means we can write P of A by B1 into P of B1 plus n equal to 2 means P of A by B2 into P of B2 plus so on you can write for up to nth term. So this is the proof of the total probability theorem. Next one, Bayes theorem. So here the sample space S having n mutually exclusive events, that is Bm intersection Bn equal to phi for m not equal to m is equal to 1, 2, 3 so on up to n. Then event A is defined on this sample space, then the conditional probability of P of A by Bn is equal to or P of Bn by A is equal to P of A by Bn into P of Bn by P of A. So now we need to expand this one. First of all, see the proof this one. First, assume this is my sample space. This sample space having n mutually exclusive events B1, B2, B3, so on, Bn. Now, what he is asking, there is no common between any two elements. Okay, so Bm intersection Bn equal to phi. Next, I want to define conditional probability, that is P of Bn by A. So, generally we know the conditional probability. What we can write? P of Bn by A means we can write P of A intersection Bn divided by P of A. So, what is meant by P of A intersection Bn? P of A intersection Bn is also written as in terms of conditional probability also, that is we can write P of A by Bn into P of Bn. So this is the product of conditional probability with individual probability. Now I know the that is numerator. Next I need to define the denominator. What is meant by probability of A? This probability of A is called as total probability. Means we can write P of A equal to P of A by B1 into P of B1 plus P of A by B2 into P of B2, so on like that. So this is the proof for the Bayes theorem. Now we need to discuss one problem related to this total probability theorem and Bayes theorem. See here what he is asking. I have 4 machines. Machine 1, machine 2, machine 3, machine 4. Okay. Next, what he is telling, machine 1 producing 10% of items, that is probability of machine 1. 10% of items means 10 by 100. Okay. Next, machine 2 producing 20% of items, that is probability of machine 2 is 20 by 100. Next, machine 3 producing 30% of items, 30 by 100. Next, machine 4 producing 40% of items. Okay, I know the individual probabilities of those machines. Next, what he is asking? The defective items produced by each machine are 5%, 4%, 3%, 2%. Now, I need to assume one defective probability. D is my defective probability event. Defective event. Okay. Now, I want to find the probability of defective events in A, that is machine 1, machine 2, machine 3, machine 4. So, means I need to write P of machine 1, means that is producing 5% items, means P of D by M1, 5%, 5 by 100. Next, machine 2, P of D by M2, that is 4% items. Next, machine 3, producing 3% items. And machine 4, producing 2% items. I know the defective probabilities also. Next, what he is asking? See here. He is asking, now an item is selected which is to be defective. Now, I need to find defective probability. I need to find defective probability. What is meant by this defective probability? This defective probability means that is getting from the total probability. That is, event A is defined on that sample space. I want to find the probability of event A. Event instant in terms of event A, I need to use defective event. So, that is P of D. So, this is called as total probability theorem, P of D. That also equal to summation of n equal to 1 to n P of D by n1 mn into P of mn. So, you can expand like, if n equal to 1 means we can write P of D by m1 into P of m1 plus P of D by m2 into P of m2 plus P of D by m3 into P of m3 plus P of D by m4 into P of m4. Now, I need to substitute all these values. That is, P of D by m1 means 5 by 100 into, I'm going to first one, that is 10 by 100, 10 by 100 plus P of D by m2, 4 by 100 into, that is 20 by 100 plus P of D by m3 means 3 by 100 into 30 by 100 plus P of D by m4, 2 by 100 into 40 by 100. So, that also equal to 0.03. So, this is the defective item is selected from the company. Now, he is asking another question, that is, what is the probability of it being from the second machine? It is coming from second machine. So, here drawing item must be defective only, and that item is coming from second machine. So, here I need to find probability of M2 divided by T, means defective item is defined, that is confirmed from getting from the machine 2, that is P of M2 by D. Simply we can write P of D by M2 into P of D divided by P of M2 divided by P of D. That is, P of M2 by D is equal to P of D by M2. We know already that value, that is 4 by 100 into P of M2, that is 20 by 100 divided by P of D means 0.03. But also getting as 0.026. Yeah, thank you. We'll continue next session.